All right, so today we're going to look at law of cosines. This is going to finish up the material for the first half of the week. So I told you Monday and Tuesday material, pretty similar in terms of like what you're doing. So we'll finish that. And then Wednesday and Thursday's material is also pretty similar. The test is going to be broken up the same way. So the first half of the test you do Thursday night for homework. That will be on 8.1 and 8.2, law of sines and cosines, 5 questions. On Friday, you'll do the last 5 questions, and that will be on 8.3 and 8.4. You'll have about 40 minutes. If you know what you're doing, 40 minutes will be enough time for 5 questions. If you think you need more time, we'll figure it out. All right, so I gave you guys a little chart earlier. We were going over the homework, and I pretty much summarized what you can use law of sines for and what we're going to use law of cosines for. So law of sines is used for angle, angle, side, angle, side, angle, side, and side, side angle. This is the only time, when I just put a box around, that you have to check for 2 solutions. You will not have any 2 solution problems in this section. No solution? Yes. With law of cosines, no solution is possible. But that's a lot easier to deal with than 2 solutions. Okay, so you'll never have to worry about 2. So the 2 additional types of triangles are side angle side. That's where you know 2 sides and an angle, but the angle that you know specifically is where the 2 sides meet. We've never had that before. If you set up a table, okay, for this kind of information, it would look like this. Just in general, something like this. You'll know a side, you'll know a side, and you'll know an angle. You will not have a full row. And if you don't have a full row, the law of sines doesn't work. So in general, that's what side angle side will look like. 2 sides and an angle, but the angle will not be in the same row. And side, 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 well, we've got kind of the same issue in terms of the table. You would know a side, and a side. So again, you will not have a full row. So law of sines will not work. And that's where law of cosines comes in. All right, so I'm going to show you what the law of cosines is. I'm going to kind of give it to you, using a formula. But the important thing is really to understand the pattern in the formula, not the specific exact thing I'm writing on the board. You really want to understand the pattern. Which apparently I need to write down. So let's write it down. So, formula. And I'm going to say it kind of generically. One side squared equals the sum of the other 2 squared. And if I stopped right there, what does that look like? Pythagorean theorem. So the law of cosines basically is Pythagorean theorem, but there's an adjustment that allows you to use this law when you don't have a 90-degree angle. Okay? That's basically what it is. So 1 side squared equals the sum of the other 2 minus twice the other 2 times the cosine of the angle across from the side you started with. That's the pattern. Now, you can start that pattern with C, A, or B if you use the letters that we use. If you want to use other letters, you could start it with X, Y, Z, Q. There's an infinite number of ways you could write it. But let's just write it the different ways we could with A, B, and C. What do you think my formula would look like if I started it with b squared? Sarah?
A squared plus c squared minus 2ac times cosine beta.
Yep. So not a different law, just a different way of writing the exact same formula. And what about if you started with a squared? How do you think you could write it? Zach?
A squared equals b squared plus c squared minus 2bc times cosine theta.
Cosine, what's that angle?
Or, alpha.
Oh. There you go. So again, letters you use, not important. Pattern, yep, that's important. So any question? It seems like you guys can see the pattern because you were able to write it these other ways. But is there anyone that has a question on the pattern of this formula? All right, two different ways you can use this formula. If you use it on a side angle side problem, you're going to have to do a little bit of both ways. One time you use it, you're going to have to solve for a side. And the second time you use it, you're going to have to solve for an angle. So you're going to use it to find a side once, then find an angle. If you use it with side, 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 well, you never have to find a side because all the sides are given. You're going to use it twice the same way. Find an angle, find another angle. So you'll just be doing an angle twice. So we're going to start out with a side angle side, which does one of each. One side, one angle. All right, so here's a pretty standard setup for a law of cosines problem. How can you tell by looking at the table that this is not law of sines? Yep.
There's not a complete row.
There's not a complete row. If you don't have a complete row, you cannot use law of sines. And that might be a question I ask you on the test. I may give you a problem and just say to you, how would you solve this? You don't even have to solve it. Just tell me, would you use law of sines? Would you use law of cosines? Just be like a drop down. Just pick which law you would use. This is law of cosines. Now we're going to solve it. This is a side angle side problem. So if you want to sketch it, you could put A, alpha, B, beta, C, gamma. So you can see when I set up my triangle, SAS. SAS falls under law of cosines. Now, when you're doing SAS, you have to find the missing side first. Okay, the reason? If you go back and look at the law of cosines, the law of cosines involves every single side every time you use it. Every side is used every time. So if you're missing a side, like we are, that's already something you're missing. No matter how you're going to do the law of cosines, you're missing the C. You cannot be missing anything else. So which version would we pick in this case based on what we know? 1, 2, or 3? Yep.
1.
We're going to do version 1. So what I'll do is just copy it over. You don't have to copy it again if you don't want to. But now that I copied it, I don't have to think about the formula as I'm trying to plug in. I wrote it down. Now I'm just going to fill it all in. Okay. I don't know C. What's A squared in this case? Francesca?
4 to the second.
Yep, and that would come out to
16.
16. What's b to the second come out to?
49.
49. Very good. And now I need 2 times a times b. Well, 2 times 4 times 7. 2 times 4 is 8. What's 8 times 7? Jeff?
56.
56. Cosine of 42. All right. Now, what could I do next on the right-hand side just to simplify something a little bit? Yeah.
Combine like terms.
Yeah, we want to combine like terms. And my like terms here are 16 plus 49. Right? You can always do addition and combine your like terms. 16 plus 49 gives me how much? Okay,
65.
65. Now you can't do 65 minus 56 because the 56 is multiplied. So you'd have to do the multiplication first. But if you want, we don't even have to do anything else on this right-hand side. I think we've done enough to condense it. We could just get c by itself and type it in all in one step. So right now you've got c squared. What would you do to get c? Yep.
Take the square root of it.
Yeah, take the square root of it. So if you type it in exactly the way that I'm writing it, then you haven't done any rounding in this problem yet. Everything is exact still. Now we're going to round it. So let's type that in. So it's the square root of 65 minus 56 cosine 42. That's not too complicated. The calculator will handle order of operations, no problem there. And you get side C is about 4.836. We'll go to 3 decimals, just like we did yesterday. Okay, so 4.836. Okay, so now we know C. Let's fill that in. Besides being side angle side, that's what it was when we started this problem. Now it's more. Can anybody tell me another type that it is now? Yeah.
Side, side, side.
Yeah, now it's a side, side, side. Because we know all 3 sides. That, if you think of it that way, we would still use law of cosines one more time. Is there any other way you could think of this problem now besides those 2? Yep.
Side, side, angle.
You could think of it as side, side, angle. Or side, side, angle. Either way. Now, if you think of it as side, side, angle, what law would you use to finish this problem? Yeah?
Law of Cosines.
You could use the law of sines, but we don't want to go down the side, side, angle road because this is the one where you have to think about 2 solution, no solution, all that stuff. So we don't want to get involved with that. So my advice is, if you start a problem as law of cosines, you finish it up with law of cosines. Then you don't have to worry about the second solution stuff happening. All right. Question on that idea? All right. So now, once you have all 3 sides, you can do anything you want with law of cosines. You can find alpha or you can find beta. So which one do you guys want to try to find? Alpha or beta? Yeah?
Alpha.
Alpha. Okay. So my suggestion is going to be write it down first, then fill it in. So there's our formula. And if you have, I see a couple people with calculators, I'm gonna need a little help doing some numbers out on this one. Well, let's do what we can. So a squared, okay, how much is that? 16. B squared is how much? 49. Now C squared is 4.836 squared.
23.384.
Thank you, 23.384. Now the next thing I'm going to need help with is 2 times B times C. Well, I know 2 times B is 14. I need 14 times 4.836. What's 14 times 4.836?
68.082.
68.082. Just going to move this. And that's times cosine of alpha, which, what was that, 42? Yeah. Oh, I'm sorry, no, we don't. Yeah, we don't know alpha. That's what we don't know. It's not 42. Sorry. Okay, so alpha is my unknown. Okay. This time it's a little different. We're trying to get alpha by itself. Well, this time everything is with alpha. So we're going to combine what we can first, and then we're going to slowly start moving everything to the other side. That's the difference when you're solving for an angle. The variable is mixed up with all the numbers. We have to move everything to the other side. Okay. Anyone see something I could do on the right-hand side first? Before I start moving.
I switched around the 6 and the 3, so it's actually 67.704.
It's 67.704
Yeah.
right there?
Yes.
Okay. Okay. All right, so still same question. Anybody see what we can do on the right-hand side first? Yep. Yep. Combine like terms. What are your like terms here? There's 2 of them. Yeah.
49 and 23.384.
Yep, the 49 and 23. So when we add those up, we get 72.384. Now, you cannot subtract 72 minus 67.704. Can't do that. And if you're not sure why, then just think of it this way. This equation I'm writing right now is basically the same problem. 16 equals 72 minus 67x. The 67 is multiplied by something you don't know. That makes it an unlike term with the 72. So they cannot be combined. So whatever you would do next to solve this equation is the same thing you would do up there. So anybody see what you would do next? Abigail?
Subtract the 72.034 from 16.
Yep, we're going to subtract that 72 from both sides. Now we're trying to get the variable by itself. So let's move the 72 to the other side. That's gone. And now while I'm writing the rest of this down, if somebody can just do it on their calculator, 16 minus 72.384. We'll take care of that in a second. On the right side, we still have the negative 67.704 times the cosine of alpha. And what do I have on the left side?
Negative 56.384.
384. Okay, so a little bit better. I'm closer to getting alpha by itself. Does anyone see what I would do next? Chris?
Divide both sides by negative 67.704.
If you're trying to get something by itself and it's multiplied by something, to undo multiplication, we're going to use division. Divide by negative 67,704. And that's going to cancel out a few things. It's going to cancel that number out. It's going to cancel the negatives. And it's going to cancel the negatives right there. Don't worry about doing that out. I would just leave 56 divided by 67. The less rounding you do, the better. So 56,384 divided by 67,704 equals cosine alpha. Well, now we just want alpha. So what are we going to do on both sides to get rid of cosine? Sarah?
The inverse cosine.
Good. We're going to take the inverse cosine. Do it on the left. Okay, we need to type that in and figure out what we get. And when we do it on the right, regular cosine and inverse cosine cancel each other out. Let's see what that is. So inverse cosine of 56.384 divided by 67.704. That gives me an angle of 33.612. And that's alpha. Now, we've got 2 out of 3 of the angles. So what could I do pretty easily now to get beta? Yep, Ashley?
Add the angles together and then subtract from 180.
Yeah, just add everything up and subtract from 180. So let's do 180 minus 33.612. And let's minus the 42. Oh, it's 146.388 minus 42. There we go. 104.388. Right, and that's about as hard as a law of cosines problem would get. With the exception of maybe a word problem, it's a little harder to make the diagram, but as far as solving it, that's what you're looking at. Any question on that? So the last tip we're going to look at is side, side, side. And inside, side, side, you're never going to be doing that. This is when we solve for a side. You're going to be doing this stuff twice. But the nice thing is all the sides are integers, so we don't have to worry about decimals, which means we'll be able to do quite a bit of it just in our head. Now, you know A, you know B, and you know C. You know all the sides. You can do anything you want with law of cosines. Can't use law of sines. But law of cosines, you can find anything you want. We did alpha in the last one, so let's pick a different one. You guys want to try to get beta or gamma? Yeah.
Beta.
Beta. So let's write our formula. And fill it in. All right. What's b squared? Anyone? Yeah.
49.
49. What's a squared? Yeah.
81.
81. And c squared? Francesca?
25.
25. Minus 2 times a times c. Well, the easy way to do that is let's start with 2 times c. What's 2 times 5? 10 times 9. 9. Cosine beta. Alright, we always get the like terms. You want to combine those first, then start moving things to the left. But don't move anything to the left till you combine your like terms. What's 81 plus 25? 106. Alright, now we're ready to move things to the other side. What would be my next step?
Subtract 106.
Okay, let's minus the 106. So we'll do that out. So we got 49 minus 106. Gives me negative 57. And Casey, what's my next step? Yep, good. Divide by negative 90. Divide by negative 90. The 90's gone, the negative's gone, and the negative is gone. So now you have 57 over 90. Don't do that out. So we were getting any rounding in this whole problem. So we're about to round in the next step. So what's my last step to get beta by itself? Chris?
Take the inverse cosine of both sides.
Yep. Take the inverse cosine. And cosine and inverse cosine cancel out. And there's your answer for beta. So it's the inverse cosine of 57 divided by 90. So that's 50.704. And that's beta. Now, you still have to do law of cosines one more time. It would be exactly the same setup as what we just did, solving for a different angle. Does anyone have any questions how you set this up to solve for a different angle? Everyone feel okay with that? Okay. The only time you wouldn't have to set it up again is if this triangle was isosceles, like, let's say this side was like 7, 7, and would that work? No, that wouldn't work. But let's say you had two sides that were the same. Well, if you had two sides that were the same, and you find one of the angles, then you know the other angle automatically, because it's isosceles. And then if you know two angles, you can add up and subtract from 180. So if you're lucky and you get two sides that are the same, you can do that problem a little quicker. Now, what about if you get all three sides the same? What would happen in that case? Eli?
All three angles would be the same?
Yeah, what would they all be?
60.
It'll be 60, yep. So if you end up with a problem that says solve and it's an equilateral triangle, well, you don't have to do anything. If they tell you the sides are 2, 2, and 2, then the angles are 60, 60, 60. Right, so that'd be the real easy case. Now, one thing you do have to check, which I should have checked right away on this one, but I knew it worked, so I didn't check it. With side, 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 you can get a no solution. The only way you can get a no solution is if you look at your sides. Any two sides added together have to be bigger than the third. If you add two sides together and they're not bigger than the third, then that's a no solution. That's why when I was trying to figure this out, I said, wait, could this be like 7, 7, and I was trying to figure out another number to make that work. So here's numbers that don't work. 2, 3, 10. No way you could make a triangle with those sides. 3 plus 10 is bigger than 2. 2 plus 10 is bigger than 3, but the problem is 2 plus 3 is not bigger than 10. Any two sides added together have to be bigger than the third. If that doesn't happen, don't even do the problem, just write no solution. Okay, so that might happen on the homework tonight. Yep.
If they equal to the same, it's still a solution, right?
No, it has to be bigger.
Bigger?
Yep, it has to be bigger. So you could not have a triangle. That would not work. 2, 3, 5. No, could not make a triangle with those sides. I could show you, but you can't do it. Okay, any two sides added together have to be bigger than the third, not equal. And if you want me to show you that after, just let me know. All right, so any question on that? So that's an example using law of cosines to find an angle. This was an example of using law of cosines to find a side and an angle. Okay, we did both. All right. So let's look at this one. So the last thing I'm going to show you is a formula for the area of a triangle. You might think, well, I already know that, right, from geometry. Does anybody know that? Remember the formula for area of a triangle? There's a 1/2 in it. Yeah.
Is it base times height divided by 2?
You could say base times height divided by 2, or you could just say 1/2 of the base times the height. Yep. Now, that formula works great as long as you know the base and you know the height. But if you had a triangle like this, you got an example somewhere, right here. You don't know the base and the height in that problem. You might say, well, yeah, 3's the height. No, 3's not the height. 3's slanted. All right, you don't know the height. The height would be if you drew a line straight down. So, how do we find the area of something like that? Well, I'm going to show you. All right. So, the base, well, you really always know the base, because you can just look at the triangle, and whatever side is horizontal, well, there's your base. Your base is 12. Okay, so I'm always going to give you a triangle where at least one of the sides is horizontal. Okay, so you've got the base. The problem is the height. I'm just fixing my diagram that I messed up. There we go. So let's take a look at this triangle. I've labeled the sides A, B, and C, just normal letters that we use. You always put alpha across from A. You always put gamma across from C. And I drew a line from the top perpendicular to the base, and that represents my height. So what I want to do is focus on this triangle in red and figure out a way I could find the height if I didn't know it. But what they would give you is potentially in a problem, I could give you alpha. That's a piece of information I've been giving you all week. C, that's a length of a side. That's a piece of information I could give you. But H would not be something I would give you. I've never drawn a dotted line in the middle of a triangle this week and said, here's the height. I give you sides, I'll give you angles. I don't give you this dotted line in the middle. So, let's see if we can find it. What's the name of side H from the perspective of alpha? Chris? What's the name of it?
It'd be A.
Well, its name is H, but what's its position in the triangle?
Opposite.
Yeah, that's a better way to say it. And what about side C? What's its position in the triangle? Yep,
Hypotenuse.
it's the hypotenuse. What trig function involves opposite and hypotenuse?
Sine.
Sine. So let's write something down. Sine equals, and I have a fraction. Ethan, what's the angle that I have circled here?
Alpha.
Alpha. So sine of alpha equals opposite over hypotenuse. H divided by C. Remember, H stands for height. So now, what would be my formula for the height if I get it by itself? Yeah.
C times the sine of alpha.
C times the sine of alpha. There you go. Now if you don't know the height, it's not a problem. We have a formula that we can use from this box to find the height using other pieces of information. Right? So let's write out what we have. Area equals 1/2 times the base times the height. C sine alpha. There you go. So there's another formula for the area of a triangle. 1/2 BC sine alpha. Now, let me draw our generic triangle, because you can write this formula 3 different ways, just like the law of cosines. Not quite as complicated as a formula as law of cosines. But if you notice the pattern here, you can write it 3 ways. So here's A, B, C, alpha, beta, gamma. So look at what we've got. We use side B, we use side C, and we used angle alpha. Where is angle alpha in relation to the 2 sides that we used? Yeah?
Jason? Or like compared to A or C?
Where is angle alpha compared to the 2 sides we used, B and C?
In between them?
It's in between them. That's the pattern. So can someone give me a different way you could write the area, but don't use alpha? Pick a different angle, and once you pick your angle, if you see the pattern, you should know which sides to pick as well. Yep.
A equals 1/2 AB sine of theta.
AB sine of what?
Theta.
That's theta.
Oh, that one. I don't know.
This one?
Gamma.
Gamma? This one?
Yeah.
You sure?
Yeah.
Okay. 1/2 AB sine gamma. So that's a second way. And anybody give me one more way? I have them all written down already. One more way. Yep.
A equals 1/2 AC of sine of beta.
Sine of what?
Beta.
Beta. Yep. So the point here is, again, not the 2 letters and the angle that you're using, because I could label the sides X, Y, and Z, and then do 3 different sets of formulas. The pattern is this. It's 1/2 the product of any 2 sides you want to use times the sine of the angle between the sides. So this is where the law of cosines would come in. If I gave you a triangle like this, and I said this side was 3, this side was 5, this side was 7, and I asked you to find the area, well, technically you could. The only thing that's missing is an angle. Doesn't matter which angle. Just find one of those three angles using the law of cosines. You don't need both, you just need one. And then do the formula for the area. So it would basically be like this problem we just did. You've got beta. You were given A, you were given C. Fill it in, now you could find the area of that triangle. In fact, let's find the area of that problem. That'll be the one we do. Okay, so I'm not going to do this one. Let's fill these sides in. So we've got 9, 7, 5, and then we've got beta. All right, so let's say 9, 7, 5. I just don't remember which one was which. A, B, C, in that order. Okay. So this was A, B, C. And what angle did we find? We found beta, 50.704. So I'm just drawing it out. Beta, 50.074. So let's find the area of that triangle using this idea. 1/2 the product of two sides times the sine of the angle between them. So anyone think they could set up my formula for the area? Yeah.
A equals 1/2 AC, AC cosine beta.
Okay, go ahead and tell me, because I need something I can actually put in on my calculator.
9 and 5.
9 and 5, okay.
Cosine 50.074.
Yeah. 50.074. Now, technically, he could have used any two sides he wanted, but the least amount of work would be to use the two sides that make up the angle we already know. So, if we do this out, let's see what we get. 1/2 of 9, that's 4.5, times 5, times the cosine of 0.74? 0.74. So the area of that triangle is 14.44. Now remember, it's area, so we should write square units. Question?
Yeah, well, kind of. For the equation, you did 9 and 5. Oh wait, I have it written on my paper different. Sorry, never mind. Continue.
You could do 5 times 9, I mean, that's the same thing.
I had 5 and 7 switched on my diagram. So it's like,
Okay.
the way I was thinking of it is like, it wasn't the way you said it.
Yeah, there's different ways you could draw it, but you should get 14.44. Now, I don't know if those were feet or inches or what, so I'm just going to put square units. So, yeah.
Aren't you supposed to use sine instead of cosine?
Oh, yeah. I don't know why I was thinking cosine. It's 1/2 the product of the two sides times the sine of the angle between them. I think I wrote sine up here, right? Fine. Just thinking law of cosines. Yeah. All right, let's type that in again. That's going to change our answer a little bit. 4.5 times 5 times the sine of 50.047. It's actually not going to change the answer that much, because if this angle was a 45, the sine of 45 and the cosine of 45 are the same. 50 is a little bit different. Not as bad as like 80 or 90, but it's a little different. So it throws it off a little bit. So it's 17.25. So it throws it off about 3, which, I mean, that's enough to get it wrong. 17.247, let's say 17.25. Now, that wasn't too bad because we already did all the work to get this angle. But if we didn't know the angle, you'd have to do that first, and then you could do the formula for the area. What if I told you you didn't even have to know the angle? How amazing would that be?
So,
Wouldn't that be mind-blowing?
yeah.
If you didn't have to know the angle? And we're talking earth-shattering here, right? This is crazy.
Is there a way?
Yes.
Can you show us?
Yes. See, now we're getting excited, right? So, you don't actually have to find this angle. If you know all 3 sides in a triangle, that's enough information to find the area. Not with exactly the same formula, but with a little different formula called Heron's formula. If you know the angle, great. Do 1/2 the product of the 2 sides times the sine of the angle. Just use that formula. But if you don't know the angle, don't waste time finding it. You don't actually have to. You can use this formula, and it's the square root of s times s minus every side. Now, the a, the b, and the c, hopefully you know what those are. Those are the sides. But s is not a letter we've used before. Well, you have to calculate s. That's kind of the downside to this. You got to figure out what s is. But s is very easy. What do you call it when you add up all the sides in a shape? Yep.
I was gonna say the sum, but
Well, it's so when you add them all up, it's the sum, and that sum specifically tells you the blank of the shape. Yep.
Perimeter.
The perimeter. Well, if you take and add up all the sides and then take half of that, that's what you call the semi-perimeter. So that's what S stands for, the semi-perimeter. Half of the perimeter. So S actually is not that hard to find. So let's take the same triangle we just did, and let's find the area of it again. The sides are, what are they again? 9, 7, and 5. So find the area. 9, 7, what was C? 5?
Yeah.
Yep. All right. So we've got A, B, and C. Let's start by finding the semi-perimeter. What's 9 plus 7? 16. And then if you do 16 plus 5, you get 21. And now, what's half of 21? Yep. 10.5. There you go. You got everything you need to do this. So the area is the square root of S times S minus every side. Doesn't matter what order you're doing it. You got to do S minus every side. So square root of S, and then leave spots to fill 3 things in. What's S minus A? Oh, Ethan?
1.5.
1.5. What's S minus B? Chris?
3.5.
3.5. And what's S minus C? Yeah? 5.5. Now, we've already done this. We already know the area of this triangle. It's 17.25. So let's try it with this formula, and we should get the same thing without having to find the angle. Okay, let's check it out. Square root of 10.5 times 1.5 times 3.5 times 5.5. So remember, we're shooting for 17.25, and we got 17.41. So that tells me one of my numbers. Did I copy this angle down wrong from the problem? 50 point.
Your first,
So it's 704. 50.704. Switch them. You laughing at me? That's not nice. Why don't you try teaching? This is hard. This is a hard job. All right. If you type that in, if you just trust me, you can. Well, I'll just type it. It'll be quick. 4.5 times 5 times the sine of 50.704. 17.41. And that's rounded, but when we did it with the square root, 17.41, look at that, same answer, boom. Huh? I know it's a little different, but that's because of rounding. Point is, you get the same area, and you didn't have to find the angle. 17.41. Okay. If you forget Heron's formula, not a big deal. You could use law of cosines to find an angle, but that's a heck of a lot more work. All right, so let me double check that. Okay, 1, 2, 5, and 6 are all law of cosine problems. Once you finish those, you're done with law of cosines. 13 and 14 are area of a triangle problems. 17 is area of a triangle. And so is 18. I think 19 is the only word problem. So technically, yeah, you're going to need law of cosines on the word problem. So that's the homework for tonight. We'll take a look at 3 tomorrow.